On June 15, 2025, the mountains near Qom, Iran shook, not from an earthquake but from the impact of America's most powerful conventional weapon. The United States had deployed the GBU-57 Massive Ordnance Penetrator, or MOP, targeting Iran's Fordow fuel enrichment plant. This was the moment the world had dreaded, a last-ditch effort to halt Iran's suspected nuclear ambitions. Fordow, buried deep within a mountain, was considered nearly invulnerable, a fortress for Iran's uranium enrichment. Years of tension and failed diplomacy had led to this high-stakes gamble. The risks were enormous: regional war, economic shock, and the possibility of failure. For the US, success would mean neutralizing a critical threat. For Iran, Fordow's survival would be a symbol of defiance. As news broke, the Pentagon confirmed a precision strike, while Iranian media claimed total failure, showing images of undamaged facilities. But the truth was hidden deep underground, beneath layers of rock and a revolutionary new material. The world watched, uncertain. Had America's ultimate bunker buster met its match? The outcome would redefine modern warfare and the future of military defense. The battle between the bomb and Iran's superconcrete had begun. The stakes had never been higher. The GBU-57 MOP is the largest conventional bomb in the U.S. arsenal, over 20 feet long, weighing 30,000 pounds. Its dense steel casing and 5,300 pounds of explosives are designed to smash through the world's toughest bunkers. Guided by GPS, the MOP can penetrate up to 200 feet of reinforced concrete before detonating. Only the B-2 Spirit stealth bomber can carry this behemoth, flying undetected into hostile airspace. For the Fordow mission, B-2S launched from Missouri, refueled mid-air, and arrived over Iran under cover of darkness. The B-2 and MOP together represent the pinnacle of American air power: stealthy delivery, overwhelming force. The MOP's existence is a warning: no target is safe. But until Fordow, its power was untested against the world's most fortified site. The world was about to see if America's hammer could shatter Iran's anvil. The mission was more than a strike. It was a test of technological supremacy. Would brute force prevail, or would defense outpace offense? The answer would echo far beyond Iran. The future of strategic deterrence was on the line. Fordow isn't just a facility, it's a fortress. Buried 300 feet beneath the Alborz Mountains near Qom, the mountain itself is the first line of defense, shielding the enrichment halls from almost any attack. Thousands of centrifuges spin in chambers protected by solid rock, the equivalent of a 30-story skyscraper overhead. Fordow's design is a network of tunnels and halls, compartmentalized to contain damage and ensure survival. The entrances are fortified, guarded by air defenses and the Revolutionary Guard. Most bombs would barely scratch the surface. Even advanced bunker busters struggle to reach these depths. Fordow was built to be invulnerable, a lesson learned from past attacks on nuclear sites. Its hardened nature makes it the ultimate breakout facility. Once nuclear material is inside, it's nearly impossible to destroy from the air. For years, military planners saw Fordow as a point of no return. Its survival would be a strategic victory for Iran, a challenge to global non-proliferation. The world's most advanced weapon was about to face the world's most hardened target. The outcome would set a precedent for underground warfare. Fordow was more than a site. It was a symbol of Iran's nuclear ambitions. The fortress in the mountain was ready for war. Fordow's natural armor was reinforced with ultra-high performance concrete, UHPC, a material far stronger than ordinary concrete. UHPC is a dense mix of cement, sand, quartz, and steel fibers, engineered to absorb and dissipate massive impacts. When struck, it deforms, rather than shatters, blunting the force of even the most powerful bombs. Iran spent years perfecting this defensive concrete, anticipating attacks from advanced bunker busters. Intelligence reports confirmed UHPC lined Fordow's tunnels and chambers, creating a man-made shield within the mountain. 1 foot of UHPC can equal several feet of standard concrete, multiplying the site's effective depth. The GBU-57 was designed for hundreds of feet of regular concrete, but UHPC is a different beast. The contest was now kinetic energy versus cutting-edge material science. Could America's bomb break through Iran's engineered defenses? The answer would determine not just Fordow's fate, but the future of underground warfare. The world's most advanced bomb was about to meet its toughest challenge. The outcome would be a benchmark for military engineering. The battle lines were drawn, steel and explosives against super concrete. Only one would prevail. In total secrecy, B-2 bombers lifted off from Missouri, each carrying two GBU-57S. Their route was long, refueled mid-air, and shrouded in stealth to evade Iran's defenses. As they neared the Alborz Mountains, tension peaked, the world's most advanced bombers against one of the most defended sites on Earth. The mission was a choreography of precision bombs aimed at GPS coordinates above tunnel entrances and critical chambers. The first bomb cleared surface rock, a keyhole for the next to burrow deeper. Each impact sent shock waves through the mountain, the final bomb detonating deep underground. For the pilots, it was over in moments, a sharp turn home, leaving chaos behind. On the surface, dust and debris erupted, but the real battle was hidden far below. Had the bombs reached their mark, or had Iran's fortress held? The answer would come not from the pilots, but from intelligence and satellites. The world waited for evidence of success or failure. The fate of Fordow was buried in silence and stone. The mission's outcome would soon be revealed. In the aftermath, information was scarce and contradictory. The Pentagon confirmed a precision strike but offered no details. Satellite images showed massive craters and landslides above Fordow, evidence of a powerful attack. Pro-Western analysts claimed success, pointing to the devastation. Iranian media countered with footage of intact facilities and calm technicians, declaring the attack a failure. They invited inspectors, projecting confidence and control. Satellite images revealed only the surface. The truth underground remained hidden. Intelligence agencies turned to seismic data and intercepted communications for answers. The world was left with two narratives, one of destruction, one of survival. The real story was buried deep, waiting to be uncovered. As experts analyzed the evidence, a consensus emerged. The bombs had failed to destroy Fordow's core. Seismic data showed detonations shallower than the main enrichment halls. The combination of granite and UHPC had blunted the MOP's power. U.S. officials claimed the attack disrupted operations, collapsing tunnels, severing power but not total destruction. Iran declared victory, its engineering having withstood America's best. Independent analysts agreed. Fordow was damaged, but its heart survived. The GBU-57 had met its match in Iran's fortress. The lesson was clear. Defense had outpaced offense. The arms race had entered a new phase. The world's most powerful bomb was no longer unstoppable. The Fordow strike changed everything. It proved that advanced engineering and materials could defeat even the most powerful conventional weapons. Nations worldwide took note. Bury deeper, build stronger, survive longer. The arms race shifted underground with new super-hardened facilities and smarter defenses. For the US, the MOP's limitations forced a strategic rethink bigger bombs or new tactics. Physics and cost make ever larger bombs impractical. The future may lie in unconventional methods. Thermobaric weapons, sabotage, cyber attacks. The era of brute force is fading, adaptability is key. The contest between offense and defense is now a battle of innovation. The subterranean arms race has only just begun. The Fordow incident marks a turning point in military strategy. The age of bigger bombs is giving way to smarter, more nuanced approaches. Success may depend on cyber warfare, electronic attacks, and special operations, not just brute force. Defenses will grow deeper and smarter with new materials and active countermeasures. The lesson: every offensive innovation breeds a defensive response. The scarred mountain near Qom stands as a monument to this cycle. The future of security may lie not in stronger weapons but in smarter strategies. And perhaps in diplomacy. The world must now decide which path to follow.